Hello everyone. I have another video for you on CalcPlot3D. This time we are going to learn how to look at vector fields. So it's pretty intuitive here. You're just going to go to Add to Graph and you're going to go straight to Vector Field. And we're going to see that it's really comprehensive. So we can look at 3D versions and 2D versions by looking at Restrict View to 2D. So we can handle kind of anything that we will see in class. I'm just going to go with a very standard one, x, y, z here to start out. So here, all vectors should be pointing outward from the origin, just kind of emanating from the origin. So if I click first, you're going to note that this is not very 3D, right? I have everything just in the xy plane here. The reason for this is the number of vectors box here. So when it says 9 along the x-axis, if I just move this along so you can see the x-axis better, it's 1, 2, 3, 4, 5, along the y-axis 6, 7, 8, 9. So you're seeing the 9 vectors along the x-axis, also 9 along the y-axis, but there's only 1 along the z, and it's at height z equals 0. So if you want this to become 3D, you want to change this. I'll just make it 9 just to have all of them be the same. And you get to see this. It is a bit much, right? So this is one of the drawbacks of the 3D. You do want to probably play around with the settings a bit because this is super cluttered. It helps a little bit that things are different colors, so you can kind of tell when things are in different octants, right? So like this stuff that is darker is in the back. This lighter stuff is here in the front, but it's still not very easy to see. So some things you can do is first you can just simply change the number of vectors along each axis. So let's see what happens if we go 7, 7, and 7. Okay, it's a little easier to see what's going on. Certainly I can see that stuff is kind of emanating out, especially as I rotate around. But if I ever fix a view, it's still pretty cluttered, right? I can kind of see that this light blue is in the back and the darker blue is in the front. The green is in the back and like this, I don't know, purplish or darker gold here, and then I don't even know what color this is toward the front, but still a little hard to tell. You could go down to 5. Whoops, I want 5 in each. And then this becomes a lot easier to tell, right? So much more spaced out, nice to look at. But maybe that's not enough vectors for you. So if we keep it at 7, and I do, by the way, like to use an odd number of vectors, primarily because I get the same number on each side. So here I have 3 on the left, 3 on the right, and then 1 down an axis, just because behavior on an axis is often an easier one to look at because it's when one of the variables or two of the variables are 0, and so might be easier to analyze like what your vector field, what you think it should look like just by looking at the formula. So if you keep 7, you can scale them down a bit more in terms of their magnitude. So originally we're dividing all the vectors' lengths by 4, so these are all a quarter of their actual length. So I can make it like 1/6 of the actual length or 1/8 of the actual length. And again, it just becomes a little less cluttered because they're not quite as long and they're not like running into each other basically. So these are just some options that you have. I'm going to keep it at 1/6 the length. And then I wanted to talk about one other thing that I often like to do to help me analyze these, especially when a picture is rather cluttered. And that is by looking at the 2D axes. So if I want to see what's happening in the XY plane, I can just look above from the top of the z-axis basically, and I can see that everything is kind of emanating out. So this basically looks like XY and then ignore your z coordinate. If you look in the XZ plane, like this, we see the same kind of behavior. So this is basically ignoring the y coordinate and seeing x comma like 0 comma z, and you're again seeing this emanating outward from the origin. And same thing with the yz, right? So again, you're just seeing everything emanate out from the origin. And so this is where you can kind of break down into 2 coordinates at a time and see why this makes sense as being x, y, z, and how everything is going to emanate from the origin in a 3-dimensional sense. So that's just a little helpful tip when you're looking at these things. Um, the last thing that you want to do is understand how to use restrict view to 2D. So here I'm going to actually go with something like more complicated. I'm just going to make something up here, like x minus xy. Let's do y squared, and then x plus y plus z. So I'm going to click home to see what the default view would be. That is much more interesting. Certainly not everything is going out from the origin. It's just, kind of tough to understand here. You'd again probably want to look at like the 2D pieces. So here, I'm actually going to look specifically at what happens in the XY plane by clicking Restrict View to 2D. So when you do that, you're going to notice two things happen. One, my Z coordinate just disappears entirely, and I'm only looking at this in the XY plane. The other thing is that this Use Constant Primary Color gets clicked, and so all of these are blue now. You can unclick this. I find that here it doesn't really matter in 2D. If you are doing the 3D version, I find it helpful to not click Use Constant Primary Color just because it can help you differentiate between things of different depths on the screen if they are different colors. So like we were looking at earlier when you could see like green in the back and like a blue in the front or something like that, it's much easier to tell what's in the front and back when you have different colors. So this just basically eliminates whatever's in the z coordinate. So I can actually just delete this entirely. I'm going to do the one that should point back at the origin, so negative x, negative y. Click enter, and notice it doesn't even require a third coordinate, and it just shows me this 2D vector field. So basically, if you have a 2D vector field to start with, you can just restrict view to 2D, enter in the first two coordinates, and ignore the third entirely. If you have a 3D thing, then you'll want to unclick that, and you can just deal with all three coordinates. So that's about all you would need to know. Hopefully you find that helpful, and thank you for watching.